Hello everyone. Today we are going to talk about RIP authentication. We are going to talk about summarization and default route in RIP. So let's understand RIP authentication. So RIP uses two types of authentication mode, which one is simple text and one is MD5. So there are two types of authentication: simple text, MD5. Simple text authentication does not provide any kind of security if the data is going between two devices. We can find out the simple text password and the router can become neighbor of the device who is sender. MD5, which is much secure, where information is being captured between devices, they can't become neighbor. They can see the information, they can see what information we have inside the network, but they can't become the neighbor of the device. That's why we use authentication mode MD5. And this type of authentication mode we can apply at interface. So these are interface level authentication. Now we have to define here keychain, where we create one ID and password. So we configure all these, we lock up all these things with interface. So first we create keychain, after that we set authentication mode in interface, then we apply that keychain along with authentication mode. So this is all about RIP authentication. Two types of authentication. We will configure and understand more about these. I can talk about summarization. Again, there are two types of summarization. One is automatic summarization. So RIP version 1 and version 2. Both they are classful by default and they do summarize whatever the networks we have with classless entries. Manual summarization facility is also available, where you don't want to advertise all your information with the default subnet mask. We can go further and we can manually summarize whatever entries we have in our database. So the main purpose of summarization is to reduce the number of entries, so cut down the number of entries in router. And we have to apply this command in interface. So summarization can be applied anywhere. It's not provide any kind of method where we can't apply this type of summarization in the environment where the environment is just like hub and spoke. This is saying we can apply summarization wherever we want. When the network is hub and spoke, you can apply summarization at spoke level and at hub level as well. We can configure default route in RIP and we can advertise along with the RIP updates. That's a very nice feature. For that we have command is default information originate. So default information originate will advertise default route in routing database. So let's understand the configuration in our topology. This is my topology where RIP is already running here in this topology, and all the routers, they know about all the networks. So fully converged network, we can see the connectivity between router 4 and 5. They also ping. So this is the tested network which is already running. Now I need to apply authentication mode here. So a network technician comes in morning and somebody says, okay, the authentication mode must be set on all the devices between router 1, router 2 and router 3. So all devices here I can say router 1, router 2 and router 3. You can apply between all the neighbors. It's not a big deal. So first we need to define a key. After that we need to set this key to the interface. So router 1, let me go and see this. So first we define a key and we need to apply this keychain at interface level, and we need to set the mode, which can be simple text and MD5. So first I need to create keychain, which is the keychain name RIP auth I'm creating. Key ID, this ID must match in all the devices, whichever device who is using keychain. Key string also must match. This is the password between two neighbors. Now we need to apply all this in interface. So interface here we have is tunnel 0. Let's apply at tunnel interface. IPRIP authentication mode, which will be simple text, and IPRIP authentication keychain, which we have already created, RIP auth. Now we can verify what is happening on router 1. So there is a command to verify debug IPRIP. This will show us router 2 and router 3 are advertising some routes, but I am ignoring them because of invalid authentication. So you see router 3 is advertising all the routes to router 1, but router 1 is saying invalid authentication, even though authentication is simple text. I am capturing data between router 1 and router 2 and router 3. So I have captured in Wireshark, and let's understand what Wireshark is saying. So here is my Wireshark, and Wireshark is forwarding, capturing all the information. And see here, I can see all the captures here, and router 1 is advertising. So router 1, click on this 172.16.0.1, which is router 1, and GRE tunnel. Inside GRE we can see RIP, and this message does not show. I would go further and see other message, which will be another here. This is the updated one coming from 172.16.0.1 going to this particular group, and here is the authentication mode and authentication password, which we can clearly see here. So not good solution, but we can apply and understand. So let me configure, let me set authentication mode MD5, because this is not the secure way to configure authentication. So I can go to tunnel interface on router 1 and apply this mode. So let me undebug first, undebug all, go to tunnel interface and apply authentication mode MD5. That's it. Still router 1 is ignoring updates because invalid authentication. Router 2 and router 3, they do not have authentication mode set, no keychain available on these devices. Now let me go to router 2 and router 3 and configure keychain. So go to router 2. So neighborship must be there. To do that, we need to have same key and same string password. Go to router 3, and I need to configure MD5, and need to set authentication mode. Mode will be MD5 and key will be RIP auth. So on router 1 already have, router 2 and router 3. Go to router 2 and say interface tunnel, IPTP authentication mode MD5, and IPTP authentication keychain, which we have already created. Go to router 3, let's jump, and here we go. That's it. Now again they will start sending updates, and router 1 and router 2 and router 3 all are going to accept because authentication is matching. I'm capturing some information between router 1, 2 and 3, and let's understand what type of authentication mode and verify. Can we see more about all the entries? So let me go down and we can see here latest information. So router 1, router 2 and router 3. Come to router 1's information and see. Inside GRE we have separate header, and here routing information protocol and authentication MD5 message digest, and here we see key ID, but actually the authentication data we can't see because this is MD5. Authentication is running between router 1, router 2 and router 3, which is MD5. Let's verify in again ping and see the neighborship is up or down. So come to router 1 and show IP route RIP. As we can see all the routes being learned here, and we can verify like this. Now I would talk about summarization. So to create the scenario, I would create here 4 loopbacks in this scenario on router 2. So 4 loopbacks I will advertise in RIP. Router 1 wants only one from router 2. So the requirement is router 2 will have number of entries and router 2 is going to advertise updates in RIP, but router 1 wants only one. So how do we do that? We need to configure manual summarization. So to do that, we need to first create some routes in router 2. So in router 2, I'm going to create some loopbacks to understand this. So let's understand. 4 loopbacks in router 2, interface loopback 22, and I'm giving 22.0.0.1 and 252 is subnet mask, which is /30. Again 9 loopback 25, 13th. Here we go. Let's verify. All the loopbacks are here. Router 1 did not learn yet because we did not advertise all this. So we need to advertise in our database. So router 2 is going to advertise. Go to router RIP mode and advertise all. So router RIP network 22.0.0.1 0.0.0. Come to router 1 and let's verify. Show IP route RIP router RIP route RIP sorry show IP route RIP. What's happening? Okay, so as we can see here, number of entries are coming, 4 entries. So we need to summarize all these and create one entry on router 2. So router 2 will advertise on tunnel 0. We are learning via tunnel 0. So how to do that? We need to go to tunnel interface on router 2. Need to advertise only one. So here per interface, so the command is interface level command. So we have 2 interfaces. We can configure 2 separate summarized entry on those interfaces. So IP summary address RIP, this is the network ID, and I want to combine all these. So I would say the total number of addresses will be in all these 16, because 0 to 4, 4 to 8, 8 to 12, and 12 to maximum 15. So 0 to 15, total number of 16. So if you want total 16 hosts, then we take 2 to the power 4. So I have taken 2 to the power 4. So 4 entries which were in host portion, they went to network portion, and remaining 4 bits are in host portion. So the subnet mask became like this, and this subnet mask will cover total 16 number of entries, 16 number of entries what we can have here. Okay, that's I have applied on wrong router. I need to apply on router 2. So let me again remove from router 1, because router 1 is not the originator router. I need to go to router 2 and need to apply on router 2. So router 2 is here, interface tunnel 0, IP summary address. This is summary address. That's it. Let's verify on router 1 what's happening. Previously we have learned all these entries. Now we are going to see only one entry. Show IP route RIP. Here we go. We got new entry, which is this /28, and these entries are going to expire because you see the timer became 28. Let's see, now it will be more than 30, 41. So these entries will be flushed out automatically after some time. If you want manually to rub it out, clear IP route star and show IP route RIP. Now see, we have only one entry which is coming from router 2. So this is how we can perform a manual summarization in any router and at interface level. Now I'm going to talk about default route. So we have default route, suppose on router 1, and we want to advertise the default route in routing database. So we need to create one default route which is pointing to our ISP. Let's create one default route on router 1. So router 1 should advertise default route, whatever route we have, to its neighbor. So neighbor is ISP or any other neighbor, and this is the entry I'm going to create. Already have IP route 000.192.168.1.1, which is my ISP. But still, if you see router 2, router 3, 4, 5, they have not learned anything because we have configured manual IP route zip. We have not learned any rip entry here, no default route. So we need to advertise this using a particular command, which is default information originate on router 1. So router rip command is default information originate. Now router started sending 000 in routing updates. Go to router 2, let's verify. Here we go, R asterisk. So this is coming 80 value 120, one hop count, and this is how we are learning rip default route in database. So you go to router 5 and say show IP route rip, and we can see here it's coming everywhere. So whatever information is not available in this database and you are going to send data, your router 5, this router 5 is going to send information to particular this default route, and this default route is coming from router 1. So let's say I want to send packet to a particular network which is not available in this database. So let's say tracer 10.10.10.10, which is not available in entire subnet where my information is being forwarded. So we can see is going to 2 and going to router 5, and router 5 is sending it to ISP, but ISP does not know how to send it back. So here actually the connections are not connected to my service provider and they do not have any type of route back toward router 1. So we are not getting reply back. So whatever information is not available in this subnet, all the devices they will throw information toward router 1. So this is how we can configure default route in the topology environment. Okay, that's it. I think that much information I could give you about all these features, and I hope you enjoyed the video. Thank you and bye bye.